Lesson 24, velocity and acceleration. All right, so by the end of this lesson, you're going to be able to find the first derivative of a position time function to find instantaneous velocity. And then you'll be able to find the second derivative of a position time function to find instantaneous acceleration. So you'll probably see where we're going with this. We're going to be applying derivatives to physics, really, right? So we're going to be able to find, if we have some position time function, we'll be able to take the derivative of that to find velocity and the second derivative to find acceleration, right? All right. So if you recall, velocity is just a change in distance over a change in time, which makes sense because the units are meters per second, right? And if we graph this, then if we had a linear relation like this, then it would really be the slope of the graph, right? That would be your velocity, right? The rise and the run there. Okay, so if we use that, then if a function is nonlinear, right? So if we were dealing with something like, so distance and time, and then we have a situation maybe like this, then we can find the average velocity by finding the slope of the secant line between 2 points. Now, if you remember what a secant line was, it was if you took any 2 points on this graph and connected them, right? So if you had a straight line between those, then the slope of that secant line would be the average velocity between, let's say, this time, if that was like time 1 second, and this was, a time of like 4 seconds, right? Then we can find the average velocity in that time frame. Okay? Now, you probably see where we're going with this, right? Because we've done this before, right? When we start bringing those points ever closer to each other, well then, yeah, I'm kind of getting ahead of myself. But first off, let's figure out what the average speed is, or average velocity, in this case, because they're both positive, there's no direction, of this function, right? Between the intervals of 4 and 6. Okay, so if we were going to do that, then we'd say, well, the average velocity, so V average, will just be my change in distance over a change in time. Okay, so then a way of writing this for distance, right? That's my Y values in this case. So you could say that that was D6, right? So the distance at 6 seconds, okay, minus the distance at 4 seconds over, and then 6 minus 4. Okay, so you can when you find the distance at 6 seconds, you just be plugging 6 into that. I won't do that step. You'd end up getting, what ends up being 535 minus 235 over 6 minus 4, and then that comes out to 150 meters per second.